Okay, well, good morning, good afternoon, good evening. Whenever you're watching, we're in section 6.3b. This is the second part of section 6.3. We're talking about factoring polynomials, specifically of the form ax squared plus bx plus c. And a may or may not be equal to 1. Here's our a term, may or may not be equal to 1. In section 6.2, we talked about a equal to 1, kind of made our life easy. Essentially, this section is going to be a not equal to 1, and this video is going to be talking about more trial and error and a couple more examples. So let's go over to Smartboard and see what we can do with Smartboard. Here's our presentation board. We're talking about factoring trinomials. And again, if we're talking about factoring trinomials, we will be given something like this. Here's our trinomial, ax squared plus bx plus c. We've got coefficients or numbers that are in front of each of these terms, a and b and c. It's important to put it in descending order so we know which one is a, which one is b, and which one is c. And if we've got a product, we're going to try and find the factors. This factor here, underlined in blue, and this factor here, underlined in blue. So if we're given a trinomial, then we're going to find factors. Let's go to the next page and say, here's our steps. How to factor ax squared plus bx plus c. Step number one essentially is making our life easy. Factor out a greatest common factor if there's one, because then the coefficients become smaller and the polynomial itself becomes smaller and easier to work with. If a is a negative number, then you can factor out a negative 1 from each of the terms, and that becomes positive then, and b becomes the opposite of what it was, and c becomes the opposite of what it was. And make sure you're in descending order. So step number one, always do these three things anytime you look at a polynomial. Make sure you're in descending order so we have the a's and the b's and the c's correctly. And then step number two is we're going to write out the factors in the blue. And we're going to leave a little space here for what we factor as a. In the red is our factors for a. In this section over here, in the green section, we're going to factor out c. So that's where c is going to go. C, I'm trying to underline there, C goes down here, including the signs. So how do we determine the signs? If C is positive, then it's a sum. You can think of it this way, it's a sum. And if it's a sum, then the signs are the same. If there's a sum for C, the signs are the same. So here's a positive and a positive, or a negative and a negative, because positive times positive gives us positive, negative times negative gives us negative. And then the sign on B tells you if they're both negative or both positive. If this is a negative number, then they both have to be negative. If it's a positive number, they have to add up to become a negative number. And just like I said, if C is negative, then the signs in the parentheses are opposite. So if C, this number here, is negative, then the positive times a negative gives us a negative, or a negative times a positive gives us a negative as well. Step 4 is new for section 6.3. You've got to find factor pairs of a, and that goes in the red here. So we find the factor pairs of a, and that goes in the red. 5 is not different from section 6.2. We've got to factor out c. Here's our c term underlined in green, and you've got to factor that out over here. And then step number 6 is essentially play with the combinations of 3, 4, and 5 with the factor pairs of a, the factor pairs of c, and the signs between, or I guess inside these factors, to find some way to say that your inside terms multiplied together and your outside terms multiplied together add up to give us b. And then when you get an answer that you think is correct, make sure that you check it. So let's go to an example. We did this example in section 6.2. We essentially factored out 2 as an a term into 2 and 1. We factored out 6 as our c term into 3 and 2. And then we had to, or could have been 1 and 6, 2 and 3, 3 and 2, 6 and 1. It could have been any of these green pairs, and we essentially started with 2 and 1 and found out that 3 and 2 works, because when we do the black multiplication of the inside and the outside terms, that gives us a correct summary of 4x. The outside terms multiply together to get 4x, the inside terms multiply together to get to 3x, and that gives us our 7x, and that's our ultimate goal. So let's go through a couple more examples that I'm going to just throw out at us and say, I'm going to give one more example today, and then say, now it's your turn to do some of these. So let's do 3x squared plus 7x plus 2, and we're going to factor that out. So what we have to do is make sure that if we've got our product, anytime we start with a product, we've got a trinomial. We have to say, let's make our life easy. Number one is in descending order. It's x squared, x to the first, x to the 0th power. So descending order means that these 2, 1, and 0, the exponents on the variables, are in descending order. 2, 1, 0. Okay, it's in descending order. Can we factor out any greatest common factor in any of these three terms? You really can't, because 3x squared has 3 and x's. The 7 doesn't have any 3's in it because it's a prime number, and here's an x, but there's no x over here, so there's no greatest common factor to factor out. The last step of making our life easy is if this a term is negative, then we factor out a -1, but that's a positive number, so we're all set to go. We've made our life as easy as possible. Step number 1 then says, let's factor out and write down our factors as this, and here's an x, and here's an x. So we start with that, and we say, now I'm going to factor out my green number and my red number, because here's my a term. My a term factors out to over here. It could be 3. Hang on a second. Should be green. Sorry. And I guess before we do that, we should probably go and say what are our signs here? Because there's a sign here and a sign here. If this is positive, then that means it's a sum. If it's a sum, then these signs are the same, and either they're both positive, or they're both negative. They both have to be positive because they add up to, when they get multiplied together, in our inside terms and outside terms, they have to add up to a +7, so they both have to be positive. So there's a positive and a positive. And now we just play around with finding our factor pairs of A, finding factor pairs of C, and then finding out which factor pairs work out. Now, there's a couple different ways to approach this. I'm going to probably try this. Make sure I'm writing in green. So I'm going to say that it should be green. This should be 3, that's better. And this should be 1. Now, I can write down 3 and 1 here, because really the factor pairs of 3 are 1 and 3, or 3 and 1. And essentially we can start with 3 over here and 1 over here, because this is a positive sign, and this is a positive sign as well. And there's no other choice for us to do. We could, if we wanted to, we could put down, just for fun, we could put down 1x plus and 3x plus, but essentially this would be the same, because we would, if whatever pairs we find here, we would just flip around to the other direction. If we found a 2 and 1 here, it would be 2 and 1 over here. So not to worry about where we're going to start with and where we're going to end. So let's go with, I'm going to erase this, because that is essentially a duplicate of what we've got already. So that we factored essentially our A and our C. We know that 3 goes here and 1 goes here, and we could flip them around, but we can, because this is a plus sign and that's a plus sign, then we can put the 3 here and the 1 there. And then we just have to factor the 2. And the factors of 2 would be 1 and, oops, let me put it in red. Factors of 2 would be 1 and 2, or 2 and 1. So this is where the trial and error kind of comes in. We put 1 and 2 here just to start, because we know that 1 is either 1 and 2 or 2 and 1. And now we have to make sure that when we FOIL, again, I guess when we FOIL, we would multiply the inside terms and the outside terms. And those inside terms give us a product. The outside terms give us a product, and that product has to add up to 7. So if we take a look at this, we'd say if we're multiplying our FOIL and we include only the outside and inside terms, inside term would be 1 times 1x, that gives us 1x, and the outside term gives us 3x times 2, and that gives us plus 6x. And sure enough, there is a good factorization, because if we add up these two inside and outside terms, which are like terms, 1x plus 6x does give us 7x. So we should assume that this is a correct factorization. So let's take a look at that as our correct factorization. And the way to do it is to kind of double check. So if we do our double check, we'd have to say, let's do the FOIL method. First terms would be 3x times 1x gives us 3x squared. Outside terms is 3x times 2x is plus 6x. Inside terms is 1x times 1 is plus 1x. And the last terms are 2 times 1 or 1 times 2 is 2. And then we combine these like terms, and we get 3x squared plus 7x plus 2. And that is the same as what we started, so our factorization here is correct, because essentially what we did is we took that, our assumed answer, we FOILed it We got that, and that's the same as this. So we did get a correct factorization. So that said, let's try a different example. Let's go to this one here. Let's start with, in fact, I'm going to let you guys loose on this one. I'm going to go 2x squared plus 3x plus 1. And remember, make your life easy and then put the factors down, factor out A, factor out C, determine the signs, and we can go from there. So I'm going to ask you now to pause your video, do the work, and come back and we'll discuss. Alright, so now that you've paused your work, again, we're going to make our life easy. That's going to be the first step we do. Number 1, descending order. X squared, x to the first, x to the 0th power. Okay, it's in descending order. Can we factor out a greatest common factor? There's no greatest common factor because over here our factor is 1, or our term is 1. There's nothing that can come out of a 1 except for a 1. So there's no greatest common factor that can come out to make our life any easier. Our leading term, our leading coefficient is positive. It's a positive 2. It's unwritten, so we assume it's a positive. So there's a positive there. We don't have to factor out a negative sign, so we've made our life as easy as possible. It's kind of been given to us as an easy as possible situation. So then we write our factors. Because we can't make our life any easier, we write our factors. We have to determine our sign. Determine the sign is positive. If C is positive, it's a sum. If it's a sum, then they're the same. The signs are the same. If the signs are the same, then when we FOIL this and multiply our inside and outside term to kind of make a smiley face there, when we multiply our inside terms and our outside terms, they have to add up to this, and that's a positive number, so then they both have to be positive. Because if they were both negative, that would turn out to be a negative number. So really, now we're going to start playing with factorization of 2 and 1, and this is really kind of a gimme here, because if 2 is factored, it could be either 1 and 2 or 2 and 1, and just like over here, because the sign is positive, 2 can go in either place as long as the other place is 1. So I prefer to start this way, 2 and 1. And now, what's the factorization of 1? Well, 1 is 1 times 1, and boom, we should be done there. So there's 1, there's 1. And now, that should be our factorization because essentially there's no other choices that we've got. So if we FOIL, let's try to FOIL this out and do our double check. If we FOIL this answer out, because this is what we assume is going to be our answer. If we FOIL in blue, we do the first. 2x times 1x is 2x squared. Outside is 2x times 1 is plus 2x. Inside is 1 times 1x is plus 1x. Last is 1 times 1 is plus 1. They're all positive because all these signs up here are positive. And now we combine our like terms there and we get 2x squared plus 3x plus 1. And that's our FOIL. And is that the same as up here? 2x squared plus 3x plus 1. Our check gave us a good check. So that is a correct factorization. Alright, let's go to another one that's maybe a little bit more challenging. And in fact, before I do that, I'm going to go back here and I'm going to say, you know what, I'm going to assign some homework just to say, you know what, here's for your homework, you're taking notes, and your homework question, or your kind of hall pass to get into my class tomorrow is solve this one here, 2x squared plus 3x plus 1, and not necessarily solve it, but factor it. So tell me what the factors are. So there should be an x here, and there should be an x here. You need to tell me those two numbers there. Alright? So that's going to be our homework. Now, you can go back to that when we go back to it, but I'm going to say, let's go on to maybe some more challenging ones. Let's try this one here, where we've got, in fact, here, I'll write it in black. Let's try this. (5x squared) plus 13x plus 6. Alright, so again, we've got to always make our life easy. We've got to look at this and say, hey, let's make our life easy. Number 1, can we make our life easy? Let's factor out, let's see, number 1, descending order. X squared, x to the first, x to the 0. Can we factor out a greatest common factor? Here's a 5 here, it's a prime number. Are there any 5s here as coefficients? Nope, no numbers can come out. There's no x's here, and there's an x and an x, so really there's no greatest common factor. Is there a negative 1 here? There's not. 5 is not negative, so we don't have to factor out a negative 1 to make our life easy. So we have to move forward with this as easily simplified as possible, because it's been given to us as easily simplified as possible. So now we have to look at our A term and our C term, and we factor out our A term over here. And we say, well, it could be, well, and I guess even before that, let's take a look at our signs. This C term is a sum. If it's a sum, then these signs are the same, so they're either both positive or both negative. They have to be both positive, because when we do multiply the inside terms and the outside terms to get a smiley face, we have to add up to this inside term here. So these both have to be then positive, or plus signs. Now after that, we start playing with our 5 factorization, and again, just like before, here's a 5 and here's a 1, because if we put 1x here and we put 5x here, it's essentially the same thing, because we've got a plus and a plus, and then the factorization of 6 goes on over here. So now let's take a look at 6. How do we factor 6? Could be 1 and 6, could be 2 and 3, could be 3 and 2, could be 6 and 1, and that's the factorization of 6. And we have to do this one down here, even though it's a repeat of these up here. 2 and 3 is the same as 3 and 2, but they're in different positions. And when we FOIL it out, multiplying the inside and the outside terms, we will get something different. So we can start with then 1 and 6 and say, well, let's see, we're looking for 13. And this is something you could probably do in your head if you're comfortable enough with it. 1 times 1 is 1, 6 times 5 is 30, 30 plus 1 is 31. You know what? That doesn't work. So then you go up and say, there's my trial and error. There is my trial, and I did a little, in fact, it wasn't even an error, it was just a trial, but you have to rule that one out. And we can go 2 and 3. And in your head, you can say 2 times 1 is 2, 3 times 5 is 15. You know what? That's still too much. So we go through and say, no, that one doesn't work either. Go back to our markers and say, that one doesn't work. Put in maybe 3 and 2. 3 times 1 is 3, 2 times 5 is 10. Well, sure enough, that should work. So if we go down here, for our inside term, it would be 3 times 1x gives us 3x. Outside term gives us 5x times 2 gives us plus 10x. And that, when we add them up, gives us like terms of 13x. And that's enough. That is, in fact, right there, what we're looking for. So to double check our work, we can do the blue FOIL. We can say we've got to FOIL our suspected answer. So this is our suspected answer, or our expected answer. That's the answer we came up with. Let's FOIL it out. What's our first term? 5x times 1x gives us 5x squared. Outside term is 5x times 2 is 10x. Inside term is 3 times 1x is 3x. Last term is 3 times 2 is 6. Combine the like terms, we get 5x squared plus 13x plus 6, and does it work? That's the same thing as what we started with, so that is a correct factorization, so that checks out, and we're all set. Let's go to another one. And let's go to one where we've got to do a little bit more factoring. So let's take a look at something like 6x squared. And this one, I'm going to probably ask you to stop for a little bit. Plus 13x plus 6. And now, number one, I'm going to say stop the video here. See what you can do with this, knowing that you've got to factor out 6, and you've got to factor out 6. And they have to go in 2 different places. We've got to factor, I guess, even first step, we always have to say, can I factor out a greatest common factor? Is it in ascending order? And do I have to factor out a -1? So I'm going to ask you to do that, and then we'll get together. All right, so we have, let's see, we've been given a trinomial here, and we're going to say, let's factor it. First step is it in descending order? 2, 1, 0 are the exponents, so yes, it's in descending order. Is there anything that's common? Is there a greatest common factor? There's no x over here, so they can't factor out an x. 13 is a prime, so we can't factor out 13 out of 6, so we've pretty much got what we've got. And then the next step is we write our factor skeleton, let's say, and then we determine signs, and we say, well, this is a sum, so if it's a sum, then these have to be both the same. They're either both positive or both negative as far as the signs go. They are both positive because our inside multiplication and our outside multiplication has to add up to this number here, and it happens to be positive. So they're either both positive or both negative. If they're both negative, it would be a negative number here. They both have to be positive. And now comes the trickier part, because we have to factor 6 to go in here, and we have to factor also 6 to go in here and there. So now we have to write down the factors of 6 that go in here and the factors of 6 in red that go in here, because C gets factored over here, A gets factored over here. Now here's a way that the book kind of looks at it, and they say, you know what, if we write out all the factor pairs of 6 over here in green and the factor pairs of 6 over here in red, we can maybe come up with a solution or some way to kind of look at it maybe a little more logically. This is a different way to approach it. So let's take a look at 6 factored. In other words, our green factor, and we're going to put in, let's see, hang on a second, I'm going to change to black. We're going to put in here a couple different choices, because 6 in green can be factored as 1 and 6, and it could be factored as 2 and 3, 3 and 2, and 6 and 1. But essentially this is a duplicate of that one there. So let's take a look at, because these are both positive signs. We could, if we switch the 3x and the 2x, it'd be the same thing as up here. So now we can look at the factors here of 6 in red and say the red has to go here, and say, how do we factor that? Well, it could be 1 and 6. It could be 2 and 3. And I'm getting a little crowded here, so I'm going to erase this down here and say that's a possibility down here, but I'm going to extend this a little bit. So let's erase that down here and say, let's go back to our marker and say this could be 1 and 6 for our factorization of 6, and the possibilities here are 1 and 6, 2 and 3, and make sure it's red, 3, 3 and 2, or 6 and 1. But if you look at this, if you look at 6x plus 6, because the plus sign would be down here, and we're just writing the numbers down here to get an idea about what they could be. If you look at 6x plus 6, you know what? You could factor a greatest common factor out of that, because if we have 6x plus 6, you'd factor out a greatest common factor of 6 times x plus 1. And you know what? We don't have a greatest common factor up here that would factor out. So you can rule that 6x plus 6 out, because it would have to factor out a greatest common factor. So the 6x plus 6 wouldn't work. 6x plus 3 likewise wouldn't work, because that would have a greatest common factor. 6x plus 2 also wouldn't work, and their pairs also wouldn't work, because it's a pair that you're factoring over here. So now the only factor pair that could work here would be 1x plus 6 and 6x plus 1, and that would satisfy our factorization. But would that would that satisfy the multiplication of our inside and outside terms? If it would, we would have to multiply. We'd have to multiply our, let's see, hang on a second, our inside terms and our outside terms to get 6 times 6x would be 36x, and already that would be too much. So we can rule out the 1 and the 6 as a pair, and we go to the next level, and we'd say, well, our next factorization is, let's see, put it in here in black, and we'd say this would be an x and this would be an x. Could it be a 2 and a 3? So our factorization, our next factorization would be 2. Hang on a second, make this green. 2 and 3, and what are our factor pairs of 6? That could be the same thing. Could be 1, hang on a second, could be 1 and 6, 2 and 3, 3 and 2, or 6 and 1. And again, over here we could rule out that one, because you could factor out something, a greatest common factor out of that. If we factor that one out, we have to, rule that one out, we have to rule that one out as well. This 3x and 6 could be ruled out, because you could factor out a greatest common factor, so you rule out the pair as well. So the next ones that are not, in fact, this 2 and 6 could be ruled out as well, because you could factor out a greatest common factor between 2x and 6 as a 3, so you rule out that pair as well. And you say, what's left over? 2x plus 3, 3x plus 2, and we have to say now that satisfies our factorization, but does it satisfy our multiplication of the first outside, inside, last? If we multiply the Outside terms would be 2x times 2 would be 4x. Inside terms would be 3 times 3x plus 9x, and that sure enough gives us 4x plus 9x is 13x. And that should be a correct factorization. And now if we FOIL, 2x, I'm going to move over here and say I'm going to steal some space over here. My factorization, I assume, is going to be 2x plus 3, because we're just moving over here. 2x plus 3 times 3x plus 2. And if we FOIL it out, we'd get first, it would be 6x squared. Outside, it would be 2x times 2 is 4x. X. Inside would be 3 times 3x is 9x. Last is 3 times 2 is 6. And we combine those like terms to get 6x squared plus 13x plus 6. And is that the same as what we started with up here? It sure is. So that is, right here, a correct factorization. So we just go ahead and give a check for that one. All right, the last one we're going to do is we're going to include a negative sign here, just because we have to include some negative signs to give us some ideas about how to factor out negative signs. So let's try a pretty straightforward one. Here's a 2x squared minus x minus 1. So again, if we're looking, anytime we see a trinomial and we're going to factor, we're going to do 3 different things. Number 1, greatest common factor. Is there a greatest common factor? Nope, that only has an x, that has a 1, and it's not worth it to factor out a 1. So there's no greatest common factor. Is it in descending order? There's an x squared, x to the first, x to the 0. It's in descending order. Is there a negative 1 we're going to factor out to make our life easy? There's not a negative 1 here, or a negative sign on that coefficient, so we're all set to start factoring. So we put our little skeleton up, and we put an x here, and an x there. And now we start factoring. In fact, before we do that, we now have to take a look at signs. The sign here is not the same, so then these signs are not the same also. So the important thing to look at, I suppose, would be 1 is going to be negative, 1 is going to be positive, and the negative, this multiplication of the inside term has to be 1 greater than the multiplication of the outside term, because we have to sum up to that negative unwritten 1x there. So let's see what we can do. Let's put in a, so now we have to say, let's factor out our 2 and put that here and here. Factor out our 1 in red and say, well, and put that, here and here. What is a factorization of 1? Well, 1's a prime, and there's really no choice of anything but 1 and 1. So now we have to choose, where does 2 go? Does 2 go here or 2 go there? Because it's going to be 2 and 1 or 1 and 2. And we have to have a negative 1 sum between these two multiplications. We're going to have to put the 2 right here. Sorry, I put it in green because it's a factorization of the a term. Sorry. We have to erase that. That's a 1. There should be a 1 there. Here's my green. Because we factored out 2 into 1 times 2. We factored out 1 into 1 times 1. And now, if we do our inside and outside terms, negative 1 times 2x gives me negative 2x. 1x times 1 gives me plus 1x. Negative 2x plus 1x gives me negative 1x, or negative x, and that's what we've got. So now let's try to FOIL and see if we've do our blue FOIL to double check. Alright, so first outside, inside, last. First terms are 2x times 1x gives me 2x squared. Outside term, 1x times 1 is plus 1x. Inside term, negative 1 times 2x is negative 2x. Last, negative 1 times positive 1 minus 1. We summarize these like terms and we say 2x squared minus x plus 1x minus 2x is plus 1 minus 2 is negative 1x minus 1. And that is what we started with right up there. And sure enough, that's a correct factorization. We've correctly factored right there. Alright, bring your homework to class, put your notes in my Dropbox, and we'll bring some questions to class.